All right, welcome everybody to the December edition of SFNode. Thanks for turning out. Hopefully folks are enjoying this new live format that we're doing. Hopefully you're trying out the Rambly site that we've got going. So definitely want to thank you, everyone who's kind of endured through all this, through 2020. I know it's been kind of a interesting time to try to be something that is mostly in person and having to make the shift to digital only. So really excited for tonight. We've got a great speaker, James Snell, who is a Node core contributor, as well as longtime fan and favorite of SFNode. Before we get into that, let's jump into some of the fun details. First of all, contact us. We are still trying to hold monthly meetups. We would love more speakers. So if you have some interesting things that you've been working on throughout quarantine that you want to highlight, things that you've learned through your job that you want to kind of share with the broader community, please head over to GitHub, SFNode, and open up an issue. We'd love to hear from you. Again, meetups are a great way to have your very first talk if you're interested in giving public talks. And they're also often a launch pad for folks that want to get into conference speaking. If you also want to just get a hold of us on Twitter, we are at SFNode, and we have an email address at teamsfnode@gmail.com. And hopefully you can see the stream live at youtube.com/sfnode. We also keep all of our recorded versions there for posterity, so if you're unable to attend any of our online meetups, you can always show up a day later and see the recorded version. Code of conduct. Even though we are remote, we still are kind of interacting with other people, and we find it very important to remind everyone that we do have a code of conduct for SFNode with the goal of just being nice to each other. There's a lot of stress in this world already, so really be nice to each other. The details of our code of conduct are here. If there are any violations or any issues that come up in communicating with other members of the SFNode community, please reach out to the organizers so we can go and address it. Finally, Rambly. If you haven't had a chance to watch SFNode in Rambly, we highly recommend it. It's a great way to be able to interact with other people watching the stream. The live YouTube stream is embedded inside of Rambly, so you can walk around, watch and listen the live meetup while conversing with other members of SFNode. So it's a lot of fun. We'll all be in there afterwards as well, but we highly recommend for anyone on the live stream, if you want something a little more interactive, you can join us at Rambly/SFNode. All right, so before we get started, again, really excited to have James on board. He's been involved with Node for such a long time. Depending on how long you've been at SFNode, he almost needs no introduction. But I'd love to turn it over to Disha if he wants to say any welcoming words about James. Cat check.
That ultra smooth transition. Sorry, I got Kitty midway through. I need to take my mute off. Yeah, James. So at this point, you're one of our longest tenured active TSC members, aren't you?
One of, yeah. There's been there since 2015, so been a while.
Right on. Yeah,
it's a lot has definitely happened since then. So it's the project has evolved quite a bit.
Awesome. Cool. Well, without further ado, we'll do a quick transition and we'll let James jump into his talk about Node 15.
Okay.
Here we go.
Oh, you may want to drop out of Rambly then. I see you're in there. That'll get rid of the annoying echo.
I'm already out. I had to be.
Cool.
Okay. All right, we good to go?
We are good to go.
Fantastic. Hello, everybody. As mentioned, I'm James Snell, J.A. Snell, pretty much everywhere, Twitter, GitHub. I do work for NearForm as the head of research. I'm also on the Node Technical Steering Committee, as Joe mentioned. I'm also the chair of the Linux Foundation Public Health Initiative Technical Advisory Committee. It's a new open source initiative that really spawned as part of the COVID response. And because of that, I'm going to start this with a very quick PSA. If you are in California, if you live in California, go out and make and download the CA Notify application. It is an exposure notification application. Uses Bluetooth for kind of checking to see if you've been close to somebody who's tested positive for COVID. It's a great way of helping stop the spread. Make sure you grab that. It just went live today. Really super important application. Anyway, let me get back to the topic at hand, which is what's new in Node 15. Node 15 came out in October. It is the kind of the ongoing cadence where we come up with a new major version of Node twice a year. Once in October, once in April. Node 15, it's really it's only going to be supported until about June of next year. We use these odd numbered releases to get new features out there, things that may be a little bit more experimental, a little more leading edge, before we go to the even numbered major versions like 16, that will ultimately end up in a long-term support cycle. So Node 15 has quite a few really interesting new capabilities that have been added to it, most of which are focused on getting greater alignment with JavaScript development in browsers or in other environments like Dino. It's really we're starting to see all these different environments coalesce on a core set of APIs. So we've gone through in Node 15 and added quite a few of these. There's message channel, there's message port, broadcast channel, abort controller. We even have a web crypto implementation now in Node 15. So I'm going to go through and just kind of talk through and show some examples of what these things are. I've been PowerPoint or Google slide. I've reached my limit for the year, so I'm just going to do this all in a code space in the browser. So we're just going to look at code. We're not going to be looking at slides. So here we go. One of the best new features that I think that we've added here is the abort controller. If you are a user of the fetch API in browsers, this is an API that's already familiar to you. Abort controller is essentially used as a way of canceling a running operation, right, or a running fetch. We have gone in and implemented an implementation of abort controller in Node itself, and have started enabling quite a few APIs in Node to use it. So, for example, if you want to set a timer, you can let that go for a second, 10 seconds, whatever. You want to cancel that, you can use the abort controller to do that now. Yes, we had set immediate, but I'll show you, how this is different in just a second. There's other uses of it. If you are reading from a stream, right? You can use abort controller to now abort that stream, cancel reading from that stream early. If you want to execute a file, using the child process exec file, right? You create a child process that's going to go off and run. If you want to kill that, right? You can use an abort controller to that. What we're trying to do is unify and standardize the model for how you abort a potentially long-running asynchronous process. So instead of having a different way of doing that for every single API, which is what we had before, we want to standardize on a single method. And abort controller really is that API that we are going to use pretty much from this point on as the way of short-circuiting or canceling a long-running asynchronous action. The API is pretty simple. Abort controller, it's one of the new globals now, so you don't have to require it. It's just always there. You create the abort controller, and it's going to have a couple of things. You have an AC signal. That signal is what we call an abort signal class. Abort signal is an event target. I'll talk about event targets in just a minute. But that signal is the thing that you actually use to listen and wait for notification that something's been aborted, right? Also on the AC, on the abort controller, you have the abort function. This is what actually triggers the cancellation to occur. So in this particular case, I'm actually showing one of the other new features that we have in Node 15, which are awaitable timers. So this is essentially a version of set timeout that you can await. It returns a promise rather than a timer. Internally, this just uses the existing set timer mechanism that's been in Node forever, but it just wraps it in a promise so that you can await it. You know, it's got the then syntax, whatever. Okay. So here I create a promise all. I have one set timeout that goes for a second, and I'm passing in the signal here as one of the options. Okay. Then I have another set timeout here that at half a second, it goes ahead and calls AC abort. All right. I'm try catching this when this first timer triggers before the longer one. What's going to happen is that this signal is going to trigger, and that's going to cause the second set timeout to short circuit early. Right. When that happens, we end up with an error, an abort error. So when I execute this, right, we get the message, the timer was canceled. All right. So here we have the ability to, using, the combination of the timers and the abort controllers to have reliable timeouts of actions, right? Oftentimes I see people using promise race to implement a timeout. They have one long running operation happening, and then they'll pair it with another promise that times out after a certain period of time. Well, in that case, when they typically do that, we get the timeout timer fire, but the other promise that's being raced still keeps going, right? It's not actually canceled, right? And it's still using up system resources and that kind of thing. Using this pattern, we can actually have proper cancellation so that that kind of situation doesn't happen. So pairing these two things together, the promises and the timeout and the aborts, really help us get much more efficient use, much more efficient applications, proper cancellation in a way that is consistent across all the different APIs. All right, so where are we using abort controller? We have a process going on. If you go out and look at the Node repo right now, you'll find a bunch of pull requests that are open, where we're adding abort controller to many different APIs. We're doing this incrementally rather than all at once, so we can make sure we get each instance correct. Some of the child process APIs, such as exec file, for instance, have signal. Some of the others don't yet, but we have pull requests that are adding it. So over the course of Node 15, so over the next probably 6 months, we're going to see more and more of these APIs get abort controller support. Event target itself supports abort controller, so we'll talk about that in a second. Some of the HTTP operations, streams, the readable streams, and as we see in this example, the awaitable timers. I'll have it. There's quite a bit more to come. Now, you do have to be careful when you are using an abort signal. It is possible to have a memory leak there. If, for instance, you attach a abort controller to an action, but then forget to clean it up. Let's say the action completes, it doesn't actually get canceled. You have to make sure you go in and remove that event listener later. So this is the action did not abort, right? That event handler was never triggered. So later you have to make sure you manually go clean it up, right? Very important. It's one of the things that we discovered when we were implementing this. It actually ended up being a bit of a hole in the abort controller specification, so that now there's an effort in browsers and basically implementations for event emitter or event target as a whole in every environment to go add the ability to add a abort signal to any event. So we can clean up this kind of stuff more automatically. But that's abort controller. Like I said, for me, it's one of my favorite new additions to Node. It's really simple. It's not something that's super flashy, but the fact that it gives us a reliable, consistent way of canceling asynchronous operations, which we haven't had before, it really shows a lot of promise. So that's the first one. Okay. So I want to move on to another one, event target. So if you're familiar with development in Node or the browsers, event target has been there forever. Everything in the browser is an event target, right? And in Node, we've had for the longest time, we've had this thing, event emitter, which is almost completely, entirely dissimilar to event target. They do the same thing, right? But in completely different ways. And we've always had this open question of, should we have event target in Node? And we never really had a satisfactory answer. So earlier this year, I just went ahead and did it. I just went ahead and implemented it, got something in there, and then the entire project really picked it up, particularly Benjamin Group G, really helped evolve it, move it forward, and get it up to spec so that it works just like it does, kind of how it does in the browser. There are some differences, and then in that Node we have no notion of hierarchy of events. So there's no bubbling up of events through an event target hierarchy. There's just an event target that emits events, right? But it's the same object. It's the same API. We have the event object there as well, right? And these are both globals. You don't have to require them. You can create a new event target. You add event listeners. It's very similar to event emitter. You create a new event and then you dispatch it, and your event handler will just receive that and process it. If you're already familiar with using event emitters in Node, it's very, very similar, right? There are distinct differences though. With the event emitter, when you emit, right, you're just given a string of JavaScript values. It can be a string, it can be an object, it can be whatever, right? With event target, it's always an event object that you're dispatching, right? And that event object encapsulates all the information for that event, okay? One of the other differences with event target is an event handler doesn't have to be a function. It can be an object that has a handle event function. So if here we look at this add event listener, instead of giving it a function, we're actually giving it an object that in turn has a handle event function on it. It gives us a bit of flexibility, especially if we talk about if your events are feeding into a state machine, where you can have this object storing the state, right? So you can use the same event handler object to handle multiple events, right? And it makes it a bit more flexible. The one thing that is important to understand, though, event target, because of these differences, is significantly slower than event emitter, right? By several orders of magnitude. If you're concerned about performance, you still want to stay with event emitter. If your primary concern is portability of code, then you now have event target, where you can write code that's going to work in the browser and in Node and in other environments that have event target there. Another nice thing with event, you can subclass it, so you can create your own event types. Add your own properties to these things, whatever, and it will just work. Okay, so what kind of things are message targets or event targets in Node? We have abort signal, the thing we already looked at, and message port, which I'll talk about here in a minute. Message port is just a communication channel. It's the primary way that we move data back and forth between the main node thread and worker threads, for instance. That message port, as it's defined in the browser, because it's available there as well, it's one of the other common APIs shared between browsers and Node now. It's how we move the data back and forth through a messaging model. Those are the only two things that we have right now as event targets. More will likely be coming in the future if we start looking at things like what WG streams, or some of those other browser type, browser APIs. right, we'll see more and more things that implement that event target API. Okay, so again, those are globals. If you want more information on those globals, if you go to the Node documentation, they are there. If you go to the globals section here, right, you can see the API for abort controller. You can come down and you can see more of the information for message port, message channel, message event, then event and event target here. All right. Okay. So that's that one. I do want to talk just briefly about message channel and message port. Again, if you're familiar with these things already in the browser, this should not come as any kind of surprise, right? There's this, the whole point of this is we're adding APIs to Node that work like they do in the browser. All right, so trying to unify those environments and try to get away from this idea that Node and browser do things in two completely different ways. The message channel is a one-to-one message channel, right? Communication channel. The idea is that you would create a message channel which has two ports, and it's the port 1 and port 2 property. And then, say if you create a web worker or a node, a worker thread, what you do is you keep one of those ports with your main thread, and then you would send the reference, you would transfer the reference to the other port to the worker. And that way, once the worker has that, the main thread and your worker thread can pass messages back and forth to each other, right, through that channel. That's really what the intention is. Message channel and message port were added to Node as part of the worker threads implementation that Anna Henningsen originally implemented. So it's been there for a while. You can find the message channel, message port all the way back to, I think Node 12 and Node 10 if you enable worker thread support. But what's changed in Node 15 is that these are now globals. Prior to Node 15, you had to require message channel and message message event from the worker threads module. Now you just have access to them as globals. They're always there. You can always make use of them. Okay. Now closely related to message channel, and this is another fun one, is broadcast channel. Broadcast channel is really a brand new API to browsers as well. Think of it as a one-to-many message channel. So whereas message channel, that existing interface is always one-to-one. There's always one port to another port, right? And you have to have the references to those two ports to pass messages and receive them. With broadcast channel, what you end up with is a global namespace for the entire process. So in the browser, it's scoped to the origin, right? So as long as your web workers and your main page all have the same origin, the broadcast channel can work across that entire origin. With Node, it's across the entire process. What happens is that you can have a main thread, you can have workers that here what I'm doing, I see I'm creating a main thread. I'm creating a broadcast channel for hello, right? And I'm setting an on message handler, and then I'm just going off and spawning some workers. Notice that I'm not sharing anything with those workers, right? I'm not telling it what broadcast channel I'm paying attention to. I'm not giving it a reference to a message port. Within the workers, though, they also go off and just create a new broadcast channel for themselves, passing in the same identifier. Okay. What ends up happening is that those workers can then share, but just by posting messages to that broadcast channel, right? It's automatically shared with everything else that's also listening on that channel. So let me run the quick demo here. We can come in here, broadcast message, or broadcast channel, index. If we run this, we see we get the hello worker, the hello message from all of the workers. Okay. And that's from this, the listener right here. Okay. But look what happens when we uncomment this close and add the on message handler to all of the workers. All right. When we run this, we notice that all of the workers also get the message, right? So every broadcast channel that's listening on the same, what we call this the channel name. Every broadcast channel object that's listening on the same name will receive a copy of that message, right? Across multiple threads, it doesn't matter, right? So we have this one-to-many messaging channel now within Node. This was recently just added. I think it only went out in the 15.4 release just a couple of days ago, actually in the release. So this is brand spanking new. I'm hoping to be able to get this backported to Node 14, and hopefully maybe even back to Node 12. We'll see. But it is very useful, particularly if you have multiple workers and they need to be able to coordinate data, coordinate activity back and forth. It's a really nice way of sending that message and optimizing that communication channel. So you're not always having to go one-to-one communication back and forth. Okay. This one is not a global. Like I said, it is brand new. Within the browsers, it's global. Within Node, you still need to require it from worker threads. That might go global in the future, maybe Node 16. But we really want it to sit behind this worker threads. It's still experimental, so we want it to sit there and make you do a little bit of work to get it first before we transition that into a global. Okay. Now, one of the other new features with Node 15 that you may have picked up on, but you may not have, as I've been going through these examples. If you notice, every single one of the files here that I've been working with are MJS files, right? Which means these are ESM modules, right? This isn't common JS. This is, that you would use require. These are using the new ESM syntax, right? In Node 15, ESM now it has graduated from experimental to a fully supported feature, right? So what we're basically saying is this is stable enough to start using in production. So go forth and use ES6 modules as much as you'd like. There'll likely be different features and new things. There are still some experimental parts of it that are still being worked on. But the core ESM functionality is there. Notice we do have named imports. This worker threads, in Node, it's all written as common JS, but we have named imports from built-in modules, named imports from common JS, from modules that you install from NPM are still there. And you can use imports with both ESM modules and common JS. It just works. All right. And one of the other subtle things that you might have picked up on, this one is a little bit more. If we go back to the abort controller example, it's very subtle, is we also have top level await. All right. So typically you can only use the await syntax within an async function. All right. So if I was going to put that in, it'd be, you have an async function. Right, and then you can use await inside there. And what we really had to do previously within Node is we had to, if we wanted to have that kind of top level await, we'd have to do something like this, have a function and then call it, right? Well, now with the async, with top level awaits, it only works in ESM modules. It doesn't work in common JS. With this approach, you can have that await keyword at the top level of your module, and it just works. So we don't have to do those kind of wrappers. We still get the await syntax, and everything works the way you would expect it to work. Okay. All right. Let's see what else we got. A big one that has actually been quite controversial. Is unhandled rejections. So previously in Node, I mean, everybody who's used Node and promises for the past few years has seen this. If what happens when an error is thrown inside an asynchronous function or inside a promise, what you get is this really annoying and rather noisy warning printed to the console where it says, hey, you had an unhandled rejection, and by the way, these are deprecated, and we're going to be changing this soon. Well, that's been there for years. People have complained about it for years, and in Node 15, we finally pulled the trigger and switched the behavior. So what happens now in this particular function here? What would have happened in Node 14 is you get that unhandled rejection error. What happens now in Node 15, I'll show you, is you now get a proper error, right? That is the behavior by default. It will crash on the unhandled rejection. Now, if you liked those warnings, if you were one of the few people who actually thought that that warning was a good thing and liked seeing those in your consoles, you could still turn them back on. We can go unhandled rejection equals warn. Unhandled rejections. There we go. But then with the unhandled rejections command line flag, you can opt back into the previous behavior, right? Or you can go to an even stricter behavior. So that right now, what we do is if you get an unhandled rejection, that will get emitted as you'll get an unhandled rejection event on the process object. We also have a strict mode that we can pass in here as instead of warn, that will cause unhandled rejections to be treated as an unhandled exception. So there's a slight difference there in just kind of the code path on how it's handled. Strict means like the strictest way that we could possibly handle this. Throwing is immediately as soon as the unhandled rejection occurs. Throw gives a little bit more flexibility in how you capture and handle it. Warn goes back to the previous behavior of emitting that warning to you. And then we also have the option of unhandled rejections none, which just ignores it completely. So it gets you more to what the browser behavior is, where the unhandled rejection can be completely ignored. I definitely don't recommend none. It's not a great choice, particularly if you're using Node on servers. It's a great way to completely miss things like memory leaks, coding errors, that kind of thing. Stick to the defaults, allow it to throw, allow it to crash your process, and handle your unhandle your promised rejections correctly. So this is an important one. Not everyone likes this, but this is the safest way of running Node, particularly on the servers. So it is an important change. Okay, so a couple others. On the diagnostics side, Trevor Norris from NodeSource recently introduced a new performance metric for Node. It's based on some research he's been doing for quite a while, at least a year or two. That really stems from the fact that since Node introduced worker threads, and we now have proper multi-threading support in Node applications, basing Node performance measurements on analyzing the CPU load is no longer accurate. Right, the Node garbage collector is going in parallel. You have the libuv thread pool going. You have worker threads. You have other stuff happening on that system. Right, all these things kind of add to that CPU noise to make it very inaccurate in terms of figuring out where and when you can scale your Node application and whether it's effectively using that event loop. So this new metric that Trevor came up with is called event loop utilization. And really what it is it's a measurement of how efficiently your event loop is being utilized. Now, Trevor has a blog post out this on the NodeSource blog. As soon as I saw this and read over it, it moved to like the top 10 of my must-read list for Node performance. It's a fantastic blog post. Definitely recommend that you go out and take a look at this, read through. It really breaks down what event loop utilization is, why it's useful, and how it compares to things, things like CPU measurement, right? There's nothing that I can say here that would describe it, even remotely close to the detail that Trevor goes into. But it is, for me, it is quickly becoming one of the most important metrics that I use for node performance optimization and analysis. There is an API for it. It's built in. So if you use the perf hooks with the performance hooks module built into Node, you grab the performance object off that, and then there's a function called event loop utilization. You just basically call that, and there's a property, this utilization property on the object that gets returned. And that's going to be a number between 0 and 1. That's going to that basically gives you the ratio of your utilization. 100, if you get 1, which you really shouldn't get, that means that your node application is spending 100% of the time kind of, actively engaged with waiting for tasks to complete, right? Waiting for IO and processing files, requests, and those kinds of things. The lower that number is, means the less work that your node, that your event loop is actually doing. Right. So depending on what application you're doing, what kind of load, you're going to see that fluctuate. Right. Every application is going to kind of settle in on a kind of a steady pattern for event loop utilization, depending on what kind of load is on. It's going to take some getting used to kind of incorporate the new metric into your process, your performance analysis process. But like I said, it is one of the most critical ones that I've seen. And one of the most important advances in node performance monitoring that I've seen, that we've had in a while. So definitely one that you want to pay attention to. Okay, let's see. Let's talk about Web Crypto. Web Crypto is an API that was added to browsers for doing cryptographic operations. And so thinking about encryption, decryption, hashing, generating random values, generating keys, that kind of thing. Node has had an API for doing this stuff for a while. It's not promise based, it's all callback based, or synchronous operations, but it's been there. Browsers really didn't have this. As browsers started really getting into things like digital identity and a lot more privacy focused, a lot more powerful operations, it was recognized that they needed to have a way of getting to these crypto operations on the client side in that browser. So the Web Crypto API was added. But it works completely differently than the way Node does. Node's existing API does. And what we've ended up with is a fracture, right? Where you have crypto code that works in the browser, and you have different crypto code that works in Node. We've been asked for this for a while. There was some pushback. There was quite a few folks in Node who were just like, no, we don't need it. Finally, it just got to the point where there was no great reason for us not to have this. We already had all the crypto functionality there. We are making an active effort to align with browsers. We need just because we need, because of user demand, promise-based APIs for doing crypto. It did not make sense for us to go in and just create yet another promise-based API when Web Crypto is there. It's already used, and there's so much code out there that's already using it. So again, we want to align with browsers. So we implemented Web Crypto. Okay. Basically, what it comes down to, you have this subtle object. So you import Web Crypto from the crypto module, grab subtle. This implements the same API that you'll find in the browser, the subtle crypto object. From that, you have a number of functions that return promises, like generate key, where what we're doing here, we're generating a random HMAC key that is 256 bits in length, uses SHA-256 as the hashing algorithm, right? We're saying that we want to be able to export that, right? There's a mechanism for exporting keys so you can exchange them, store them, that kind of thing. And we're saying we want to use it for signing and verification, all right? So it'll go off and create that key. The important thing about this is that the key generation does not block the node event loop. This is happening in the libuv thread pool. All right, so you create this, it goes off and handles that asynchronously, resolves the promise when it returns, when that is done. So quite a few of the other crypto operations that are in Node are all synchronous blocking operations. In this case, all of these are asynchronous. They do not block the event loop. There's a couple exceptions to that, such as when we're importing keys. The import operation was easier to do it synchronously, and it's not as expensive as the key generation. So there are some differences there, but for the most part, all of the web crypto operations are truly asynchronous. Once we have that key, we're going to go and use sign. We're going to use the HMAC algorithm. We give it the key we just generated. Give it the data that we're going to hash. Again, this is asynchronous. Does not block the event loop. Goes off, generates the signature, gives us that digest back, and we can go from there. This exact same code should work in the browser. Right up before this. I mean, this is the only part that is node specific. How we get that subtle object, but the rest of this, it's the same code that work browser node. It just it's consistent across the board. We do have a few node specific extensions in here. They're not new methods, but they are like identifiers. So Node implements the script for key derivation, protecting passwords, basically generating secure hashes of passwords. That doesn't exist in the browser, but we have a way using web crypto. What you do is you pass in node-script as the identifier rather than HMAC or whatever else. So there are some node extensions, but they're done in a way that makes it clear, one, that they're extensions and is still API consistent with what's happening in the browser. That was a massive change. In fact, it was probably one of several massive changes that have landed in Node. In order to be able to implement web crypto, we basically had to go through and re-architect and refactor the entire crypto subsystem within Node, all the way down to the native layer. Moving stuff around, shifting things around, just so we can execute those operations efficiently on the libuv event loop. Okay. The other big thing that we've added to Node, but it is not yet in a release. It is in the Node repository. If you look at the main branch, it's there. It's something that we've been working on for a while. And it is an implementation of the QUIC protocol. If you're not familiar with QUIC, it is a new UDP-based subsystem that underlies the HTTP3 protocol. So HTTP1 and HTTP2 are all based on TCP. HTTP3 is based on QUIC, which is based on UDP. Okay. There's quite a few details on this. I have a blog post on the NearForm site that kind of goes through the basics of the implementation. But I just want to kind of show a little bit. This is not necessarily something that you could use today because, like I said, it's not out in a release, and I'll explain why in just a second. But let me just give you the basics of how it works. So UDP, we've probably all, heard the joke way too many times that I'd tell you a UDP joke, but you probably wouldn't get it, right? UDP is an unreliable protocol, right? You send a datagram, you send a series of datagrams, they'll come, receive, if they arrive at all, they'll be out of order, right? There's just all kinds of issues with it. What QUIC does is it actually adds reliability, a reliability layer over UDP. So there is a mechanism of acknowledgements that are added. You send a data packet, the receiver will acknowledge it. If one gets lost, you can just resend it, wait for that acknowledgement. They can arrive out of order. There's QUIC adds a sequencing mechanism to it. So it really goes through, and the kind of the running joke is it's just, we re-implemented TCP on UDP. But that, there's a, it's kind of tongue in cheek, but there's a lot of truth there. The one thing that it does do differently than TCP is that TLS, the transport layer security, is actually built into the protocol. You use TLS, the handshake for TLS, as the way of bootstrapping a quick conversation, quick connection, right? You cannot have QUIC without having that encryption built in, right? So that is one of the fundamental differences. Interestingly, what that ends up doing, right, because of eliminating that layering between TLS and TCP, that kind of thing, building it all together, it actually makes the handshake much, much faster. In Node, the TLS quick handshake is 60% faster than the TLS TCP handshake, which is a massive, massive difference. It uses less memory, and connections set up much, much faster. And that's not even accounting for, in TLS 1.13, you have 0 round trip session resumption. So once you've established a TLS handshake once, you're going to reuse that in future connections, right? And it shortcuts the entire TLS handshake process. The bottom line there is connections are much, much faster. All right, Quick is absolutely fantastic protocol from just a network efficiency and performance. We're seeing very good numbers. If you go out and look at all the research and the work that Cloudflare has been doing around Quick, see that there is huge benefit to this. I can't wait to be able to have Quick in a supported Node release. Now, why can't we do it? The code is there. It works. I mean, there's quite a bit of additional work that needs to be done on it. But why can't we get it into a release? Well, the challenge there comes down to OpenSSL. In order for Quick to work, there need to be some changes to the way TLS 1.3, some timing and some metadata stuff in TLS 1.3. Those have to be implemented at the OpenSSL layer within Node. Right, so Node relies on OpenSSL to implement all of the, basically all of the support for TLS. Okay, Node doesn't actually implement that directly itself. So there need to be some API changes. Now, Boring SSL as a project went off and they made the necessary changes. Boring SSL is a fork of OpenSSL. They went through it and implemented it. And then someone over at Akamai went and ported those changes that was made in Boring SSL to OpenSSL, opened a pull request and said, all right, OpenSSL project, please land these so we can deliver Quick support as early as possible. The OpenSSL OMC decided, nope, we're not going to do that until at least 3.1, which is going to be at least a year from now, at least. They're still working on OpenSSL 3. And it's going through the betas and release cycles and stuff now, right? So it's going to be a while before Node can get a version of OpenSSL that has the necessary APIs and support to support Quick. We can patch it in, which is what we've done. We basically have Akamai's set of patches patched into Node behind a conditional build flag. So in a release, they're not used. It's not actually enabled. They're there. But because those are not actually supported by the OpenSSL project, and we can't guarantee security fixes and that kind of thing, right? We do not want to ship a unsupported patched version of OpenSSL with Node. So because of that, we have to wait to enable Quick support in a release. So it's there. It's fantastic. Trust me, it works great. And if you're brave, right, you can download Node yourself, build from source. There's just an experimental Quick compile flag that you need to enable. You can grab that and start playing with it. You will run into bugs. Like I said, it's not finished, but at this point, there's no rush to get it finished because we can't actually get that support in OpenSSL yet. So that's the story with Quick. It's there. If you look at the API here in the examples, it's pretty straightforward. You create the Quick socket. You grab the Quick socket and create Quick socket from the net module. You create that. A Quick socket can act as both a client or a server at the same time, right? So it's not like the TCP you're doing one or the other. A Quick socket can be both simultaneously. Here we're saying that we're going to have it listen. We say when a Quick session is created, initiated by a client, we're going to have some setup logic. Quick is based on the notion of streams, right? So once you create a Quick session, over that session, which is a logical communication between a client and server, you can have multiple streams going at the same time. So if you're familiar with HTTP2, it's got that multiplexing capability there, right? Those can be open. Streams can be bidirectional or unidirectional. And here's the fun part. They can be initiated by the server, right? So a client can initiate the session with a server, but the server can sit there and open its own streams back to the client, which is fun. So you don't just have to wait on the client all the time. It opens up some really interesting potential use cases that are fascinating. And like I said, I can't wait for you to actually get to play with it, but it's going to have to wait a while. All right. From there, those streams are just duplexes. If you're familiar with the Stream API, you're just using that, just reading and writing data, and that's it. That's really the quick API, and we made it to be as simple and familiar as possible, right? So if you're already familiar with networking in Node, this should just be natural and should just work. Okay. Again, once you actually have the opportunity to use it. So, okay. So that's basically it. There are quite a few other things. Smaller API additions. The Web Crypto API, I definitely recommend you go through the documentation. It is an extensive API. There's a lot there. ESM modules, there are several additions to the documentation on this that go into detail how it works. There's changes to the package JSON file. There's ways of supporting both CommonJS and ESM in the same project. It's a ton of detail to go through. I highly recommend you go through the documentation, figure it out. One module I want to plug, written by Anna Henningsen, is Gen Esm Wrapper. If you have a module that is CommonJS based now, using this as part of your build process, like npm build, your pre-pack process before you publish to npm, you can have this Gen Esm Wrapper automatically generate an ES6 module that is derived from your CommonJS. So it's a really simple way of you only write the code once, but it still works in both ESM and CommonJS. Using this in a number of places, a number of different projects. The other one I want to plug, if you are using worker threads, you need to be looking at Piscina. It's a worker pool implementation, primarily written by Anna and myself. It's got pretty comprehensive API. You can use a Bork controller. It's all promises based, and the results that I have seen when used correctly can yield about a 20 to 30% performance improvement when used in applications that need it. It's not useful in every case, so it's not like it's not a tool that you're going to just throw everywhere. There are very specific types of cases where it comes in very, very handy. For instance, server-side rendering type things. So, important project. Highly recommend you go take a look at that. And with that, that's the overview. There's a lot there. There's a lot more coming, right? There's a lot of conversations that are happening in Node. It's a constantly moving, evolving project. Always love to have new contributors. If you're interested in contributing to Node, come talk to me, and I'll see how I can help you. So thanks.
Awesome. Well, thank you so much, James. Let me switch our view a little bit to get us all back on. Yeah. So those are amazing additions. I've been a long time Node user, and there's a lot of like quality of life things it feels that are kind of coming to the Node ecosystem.
Yeah, I definitely hope. I think just a Bork controller alone it's going to be one of those things that's just going to be revolutionary. So.
Yeah, normalizing how we cancel things. Some of the gnarliest code that I'd ever written and dealt with was early streams cancellation and the kind of the cleanup of all the mess that that would generate. Going and making sure you grabbed all the bits was tough. That's great, James. What are some of the big alignment points that we still have? I love all of the alignment with the rest of the open web. I think that's so important, and it was great to see not only a lot of those things, but some new features too. But like, what are the big things big rocks that we have to deal with yet?
So I know if Miles Borens is listening, or at least listening to the recording back, he'll love us mention Fetch, the Fetch API. It's a big one that in the browser that folks have been asking to have in Node for a while. It's in Dino. There are a number of challenges with implementing it with Node. The fact that we don't have a WhatWG Streams API implementation. And why don't we have that? Well, we already have 3 Streams APIs in Node,
Right.
and nobody wants to implement and support a 4th one.
Right.
But we're going to have to anyway. And things like event targets, right, get us part way there. It's starting to lay those foundations. In fact, you know, the road to the WhatWG Streams API is why I added, why I wanted to add event target, right? A board controller. Well, it's used in fetch. So, it's incrementally stepping in that direction to where we can get that. Now, there's a ton of APIs that are in the browser that just are not going to be relevant in Node, right? Pointer events, things like that, right? So we're not ever going to see a place where all of them are implemented. But I think at the very least, we're going to have to end up with having a fetch, having and WhatWG streams, and just having those there will go a long way.
Right on. Yeah, looking forward to that.
Yeah. Awesome. Well,
It'll be
thanks.
interesting. I'm not looking forward to supporting another Streams API. I'll say that.
Right on. Well, we can just deprecate the other 3, right? Right?
Yeah.
Nice and easy.
Right after we finish deprecating the buffer constructor. So, yep.
Awesome. Well, fantastic. Super excited to see how Node continues to grow, especially as we kind of partner up more with the open web standards and really, again, help coalesce and unify the JavaScript ecosystem. So amazing work. Thank you so much for everything. For our viewers at home, now is a great time to jump into Rambly. We're going to be ending the stream in just a minute here, but we are going to be jumping over to Rambly, where we can still chat with other folks that are also in Rambly that have watched the stream, and kind of a great chance to ask questions either about tonight's meetup and content or about Node.js in general. Often we try to do job hookups for folks, so if you are looking for a job, if you are looking to hire folks, come on in, raise your hand, let us know who you are, say hi. We love to do our best to kind of help keep the community alive, even though we're all at home.
If I can, I will plug NearForm is hiring. We have some jobs out there. So go to our careers page, take a look.
Awesome. Anything else as we wrap up, gentlemen?
No?
Yeah, I think we should head over to Rambly. Looking forward to it.
Okay.
Cool. Awesome. Well, thank you everyone for joining, and we'll see you in Rambly, and we'll see you in 2021.
Thanks so much, James.
All right. Bye.
Bye.